All right, welcome to inequalities and slopes. Kind of a neat little lesson for us today. We're going to show how the following is a graph of a function. It's an unknown function. We really don't know what exactly it is, but we're going to use this graph to answer the following questions, and this is going to help us for the next few days. Now, the first question says, determine where f of x is greater than 0. Now, basically, remember, from Algebra 1, we learned that f of x was equal to y. So if we're saying where f of x is greater than 0, we want y to be positive, which for us is above the x-axis. Therefore, above the x-axis. Now, if I look at the function over here, if I want to find out where this is above the x-axis, we look like we're between -7 and -3. Now we have to stop at -3. We talk about why that is, because there it is equal to 0, not greater than 0. So I might go from -7 to -3, and then it bounces back off to 3, the -3, and goes all the way to the 2. And then the last one, it's above the 8 to infinity. This is nothing new for us. We've done this before. Now, the next question, of course, says where is it below the x-axis, where f of x is less than 0. So this time we want y is negative. We want to know where y is negative, or below the x-axis this time. Okay, and that's easy enough to do as well. It looks like it's going to go from -infinity all the way to -7, or from 2 all the way to 8. Now, isn't that great? Very easy to do, looking at a graph of where it's above and below. Now, we're going to use this tomorrow, but go backwards. It's going to be kind of a fun little thing. We're going to be learning how to find inequalities from a function rather than a graph. This is vital for both pre-calculus and calculus for next year. We will learn how to solve inequalities using a process that we call sign charts. Now, a sign chart is a number line that represents the axis of the coordinate plane. Sign charts allow us to determine where a function is above or below the x-axis by using special numbers that we call critical numbers. Basically, it's the x-intercepts. Okay? In Algebra 1, you solve for critical numbers, but you call them roots, or zeros, or the x-intercepts. Now, this is an example of a sign chart. If this is my x-axis, I will have certain numbers where it crosses. It may cross at -2, 0, and 4. Now, if this is my x-axis, these are my critical numbers. What's happening here is something special. This is where the graph goes from positive y values to negative y values. For example, if it's before -2, y may be negative. If it's between -2 and 0, the y value may be positive. If it's between 0 and 4, the y value may be positive as well, and this might over be negative. And if we understand the sign charts, you can actually graph functions pretty easily. So if it's below, it has to go down. If it's above, if it's positive, it's going to go above. Now what happens here, it doesn't go below after 0, so because it goes from positive to positive, that's implying multiplicity, so that might be M2. And so we know it's going to bounce off. Goes up, it has to cross the 4 again, and it goes back down. And that's what our graph could look like, the reverse Warnow function. So let's take a look at another one like this. Okay. If I want to graph using sign charts, so my function may be over here, and we're just going to give about maybe a couple of them. Let's go across this time at -3, -1, 2, and 7. It doesn't really matter. And let's say here, let's give the signs here. Like, let's say this was positive, positive, negative, positive, negative. What would this graph look like? Well, it's positive, so it's going to go up. Because it goes from positive to positive, that's implying multiplicity, m2. So it goes up, Now over here it has to go down below because it goes from positive to negative. Negative means it's going to go below the x-axis. Then it's go to positive, which means above, and then it goes back down to negative. So we can even tell what type of function this is by looking at it. This is an odd negative function right there with how many roots. So, and it might have a degree. What would be the degree? The minimum degree would be, well, this has 2, 1, 1, and 1. So 2 plus 1 is 3, plus 1 is 4, plus 1 is 5. So this is a degree 5 polynomial. And you can probably write it out a little bit. Y equals a if you wanted to. X plus 3 squared, x plus 1, x minus 2, and x minus 7. That could be a generic equation of our function. And if we knew the y-axis, we could actually find a. Pretty easy to do. All right, you guys try one. Let's give a few roots here. All right, I want everybody to shout out some numbers for us. -3, that's cool. 0, nice job. Amit, give us a number. Pi, ooh, I like the way you're thinking. Let's do here as 4, and over here as maybe 10. And now we got to have some signs, okay? Because this would be a sign chart without signs. Let's make this negative, positive, negative, negative, positive, negative. And what I would like you guys to do is go ahead and sketch that, and we'll go over that tomorrow in class. Now, so that's one way we can graph using a sign chart. Now, but what if they give us in terms of the domain? Now, this is kind of a trickier one right here. For number 4 and 5, they're giving us the domain and what the sign is. So between -4 and -1, they tell us the graph is below the x-axis. So it's negative. Between -1 and 3, it's positive, so it's above the x-axis. Between 3 and 5, again, it's above the x-axis. So take a look. We go from above to above. So most likely there's some multiplicity going on there. Pretty easy to do. And over here, negative. Now, I'm going to make my chart, my sign chart. That's all I'm going to do. There is my x-axis. I do my sign chart to graph it. We get graphs from sign charts, and we can get sign charts from graphs, and that's going to be what we're doing tomorrow, the next day. So if it's below, between -4 and -1, so I have to look at the points here, are very important. This is where I'm starting, at -4. Here's -1, 3, 5, and I'm stopping at 9. Okay? These are our critical numbers. At -1 and 1, at -1, it's where it crosses 0. So we can actually get the roots from here. -1, 3, 5, and that's really all that we know are roots. -4 does not have to be a root, but you can treat it as a root. So that's probably, we shouldn't do 9 and 4 as a root. But here's what we do know. Between -4 and -1, it's negative, so we're below the graph. Between -1 and 3, we know it's positive because we're above the graph. See, below is negative. Between 3 and 5, again, is positive, which probably means there's some sort of multiplicity here. And between 5 and 9, negative, because it's below the x-axis. Not -1, that's awkward. There we go, just negative. So when I graph this one, it's going to be below. Now, I could draw it to the -4, that's okay, but we don't really quite know anything there, so I might start it here. Now, it's going to be above, and as we said, there's some sort of multiplicity here at 2. Crosses at the 5 and goes down. It's an M. Get it? Good. All right. Anyway, so, and that's what our graph could look like. Now, we don't know anything about the y-axis, so we can just leave it like there. So, using our sign chart, we got the graph. So I would like you guys to go ahead and try number 5 on your own. And when you're done with number 5, go on to part 2, and we're going to see exactly where this is leading us, okay?